Good afternoon. This is going to be the most interesting, fabulous presentation you've had before happy hour that you'll ever believe. So everything that we just talked about in the panel is about information management, and that's where I'll be approaching this from. This is along the lines of creating data. Yes, that's what we talked about with Ken, creating 1.2 million pieces of individualized data. What we want to do is put that together and tell a story. And we need to be able to do that to be able to convince funding to continue to happen, to continue to the improvements. So if we are going to actually tell a consistent story from the beginning of the life cycle of an asset, which supports operations, to the end of the life cycle of that asset, where it needs to be replaced, but maybe we need to look at design all over again to see if we can make it more efficient, we need information. So collecting the information and making that actually tell a consistent story, that's the goal. Yes, I am going to get into some technical ease, but it will be fascinating, I'm sure. Okay, good news is that we can actually go through it because it basically just gives you a little bit of a background as to Cohesive. It's an organization that was formed out of 9 different companies. I don't know how many of you have heard of Bentley Systems, but Bentley Systems do a lot of infrastructure management, for instance, competitors to Autodesk. Be able to create a picture of your assets. And when I say a picture, I mean a picture. So we're talking about visualization. So around the world, we've got many, many different implementations of software, which is good because we've got many different lessons to learn from different places in the world that have different levels of maturity. And there is absolutely nothing wrong in pulling information from wherever you can get it to be able to make your assets more performing. So the fundamental principle behind all of everything that I'm going to be talking about today is making sure that assets perform the way that they're designed in the context of the installation where they work for you. This doesn't mean to say that everybody is going to use an asset in exactly the same way. So as in the same story that we had earlier on, where we have different interpretations of what we do from one person to the next, from one organization to the next, we want to learn from each other and be able to apply assets in the most effective way. Now, when we get down to digital asset performance, we know why digitalization makes a difference. We know that that is far better than any kind of paper-based asset information management system. Does anyone argue with that in terms of why digitalization makes sense? Good. So the idea is, of course, that if you have information that you're capturing, you're harmonizing that data, you're turning that into real information about how your assets perform relative to their design context, you know that you're spending money in the right way, you're actually achieving what you need to do. And if we hear what the panel said previously, customer is king, the assets exist for the sole purpose to support operations. They're not just for the sake of someone to create a work order against. The asset has to have a purpose. The purpose is to meet that design need in the most effective way that it can. And we, of course, track the progress of that performing asset over time until it starts to deteriorate. But when that deterioration happens is based on how we use it, how we maintain it, and what, of course, information and funding we provide to be able to make it perform at its best. In the good old days, the reactive domain was always where maintenance of those assets started. We react to things as they happen. Create a work order. Like we talked about in the panel previously, there's a work order system. This is good. We need to capture that history against the individual assets so that we know what we're doing, when to replace an asset, how much to spend, what is it worth, do we need to redesign? A better way to do it is look at an algorithm based on condition. So we don't just look at 1.2 million individual pieces, and I'm not decrying what happened earlier in the panel by any means. It's just a matter of pulling the information up a level. What do we have about the context of that asset to tell us why we might have an issue? Once we fix the actual root cause of that issue, we don't have the issue anymore, rather than keeping on responding to the issue. It's in the same way that we're looking at doing preventive maintenance based on need instead of just simple points in time. If we do it based on time, we have no context to say whether that's good, bad, indifferent. Is that improving the performance of the service itself to the customer? And that, again, is where we're trying to get to. When we actually want to move to the future, We're using that information in another more productive way, which is to create predictions. And this doesn't necessarily mean a fairy tale. This is using AI, this is using behavioral analytics, this is looking in terms of time, over time, to be able to say, how many different scenarios can we create to be able to be fairly sure that we need to maintain an asset in a certain way so that it is performing at its best? And how do we feed that back into the design stage so that next time we do this, and there will be a next time because everything has a life, even if it is 60 years like the MTA, not that that was intended, but again, how much can you trust an asset's performance over time is all based on information and its performance. So if you can predict when that performance is going to fall off, you can create a funding plan. That funding plan then creates a capital investment plan. You know which assets need to be replaced and when. That will actually allow you to justify the next movement forward in your performance as an organization. So if we're using engineering data, condition assessments, and we're using it to help provide information back to compliance and regulatory bodies about how well we are spending that money, that will give us the connectivity between all of the asset lifecycle. So not just looking at everything in isolation. If we put in a system, and I'm not saying a system is a solution, we put in a system to take care of operations and maintenance, how does that connect to the rest of the cycle? Maybe it does, maybe it doesn't. It certainly should to be effective. If we can feed information in right from the design concept stage, keep it evergreen, keep it live, move it all the way through to decommissioning, and feed that back in at the start again for the next cycle, we've achieved something. We keep the asset alive, we keep it performing as it should, but we also keep the information alive. And that's the key part. We need to actually keep evolving the information. The information can become static, it can become stale, it turns into PM work orders. What we want to do is to create this into a behavioral analysis of the process, supporting the customer service. If we tie all of the PM work orders directly back into how do we achieve better customer service, that's when we really get intelligent about what assets we need to support the operation. We know in the rail industry, and I've been around for a while and started out London Underground in 1994 and kept going with Amtrak and so on. We know that it's an incredibly complex environment. And it's interesting from the point of view of the passenger. The passenger couldn't care less about the assets other than they work. And you get from A to B as necessary with a reasonable amount of money involved. What we have to do as asset managers and providing the service is to worry about all of these assets. And we have to do that in an efficient way because, of course, it is taking it off the bottom line. We need to be able to discover all of that information about the assets that we have. Some of those assets may have been in the ground for 140 years, but we don't have any information. So what do? We have to go back and use a greenfield approach to capture information and then use those standards to try and apply them to information that we need to capture about assets that are critical, but we don't know where they are or how they function, which other assets they're connected to. Again, it's not just a matter of looking at an asset as an individual item, but part of a process. So if we can, bit by bit, move through the cycle of capturing information as critical assets and critical service requires, then we can create something like this, which is a visualization of how the assets actually interact. And then we get an understanding of what might be causing some of those issues that we need to go out and work on. But we can't do that if we don't apply the context. So the next part, it is leveraging digital innovation around about the asset lifecycle, that loop that we were talking about, from design through to decommissioning and back again. All of these pieces could be applied. Again, I'm not to scare you by any means. It's just not to say that you have to do every single one of them at once next week. The idea is to make sure that you do what you need to do to get to the next step in the cycle. So like I said, corrective maintenance to preventive maintenance is an improvement. Preventive maintenance to predictive maintenance is a better improvement. Capital investment planning out of predictive maintenance is even better, and build over time. As information becomes available, as you make it a standard. If one of the things that we talked about in the panel just now was We have silos of information. We all know that. There's a lot of spreadsheets being handed backwards and forwards that could be far better applied as a unit, where we understand all the relationships between that data. And then everybody's looking at data in the same way. So here's a nice graphic for you. This is technology speak for CDE being a common data environment for all of those inputs to the process. What we need is a visualization and data connect hub where it pulls all of the logic of that information together, all the understanding about how those assets interact in the process, so that everybody's talking the same language. And now there's no arguments about which data is right or wrong, which version of information is mine or yours. It's ours. Then we pull that together, use that as a way to be able to look at maps, build in 2, 3, and 4-dimensional viewers so that we can see over time the difference that we're making. And again, the whole point now is to come back to the start and look at what I can do to continue funding improvement. So if we're looking at a track chart like this, it's fairly easy to see where the hotspots are. We have those red lines that show on the geometry or the track gauge or the ultrasonics or whatever we're doing to the track where we have a problem. We need to apply work at those locations. But how many other things might be wrong in the same location so that we can apply one crew with the minimum disruption for our passengers, rather than thinking about it from the point of view of I'm signals, I'm communications, I'm mechanical, whatever other service may be. We need to look at it more holistically. We need an information management system that will raise that information value up and not be able to be so territorial. So what we'd like to do, of course, is address this with the culture. We can't leave that out. We can't simply say that there's a whole new way of working, forget everything you've done for the last 100 years. We need to be able to bring people with us, but see the value of the information. Because, of course, if we apply a better field support to fixing these issues, we have less disruption. People are more likely to ride the rail instead of jump in their car. And there are many opportunities for improvement. If we're talking about the Holy Grail, then we could be looking at something which is pure greenfield, and this may happen, for instance, in between Austin and San Antonio, like we were talking about before. Brand new rail, perfect opportunity to capture information about a conceptual asset that turns into a physical asset that turns into a maintained asset. But again, we don't have to rediscover that information. We've already got it. We put it into a design, it becomes reality, now we have to take care of it. There's a great potential for us to only focus on capital development, but everything we put in the ground requires maintenance. Everything requires us to know about it, where it is, how it's performing, whether we could do better with it. So all of this information here about what contributes to the higher speed 2 service in England will become centered around customer service. And it will require maintenance, and it will require development when we extend the line, maybe. So we will see. So, yeah. The justifying ongoing involvement is pretty much what I already talked about. Apologies for the font, I think it doesn't like it. But the idea is that it feeds back into a constant self-justifying model. So for instance, if we say that we have got the best out of the asset's performance that we know that we can get, and that was the purpose of my question earlier on, was how do we know we're comparing to a baseline, to a starting point, so that we can justify and tangibly show improvement, then it's fairly easy to show that these investments and these improvements make a difference. And when we do that, we're able to justify further investment and in further improvement. So taking it back holistically, when we've got all the information gathered together, we tie it to a project, we tie it to a program, we can justify why that investment makes sense. Socially, economically, from a governance point of view, environmentally, for all the ESG requirements that we may have, and of course, financially, which is not the whole story by a long shot. It's the benefit of providing this service to the public. Any questions? Otherwise, thank you. Stunned silence.